Alright, so in this video we're introducing some new rules that are true for every normal distribution, even approximately normal data. It's the 68, 95, 99.7% rule. Very important rule, make sure you know it. Okay, so essentially what this rule tells us is that 68% of the data in a normally distributed data set is going to lie within one standard deviation of the mean. See figure A right here. Within one standard deviation of the mean, remember the mean's always in the middle, so one standard deviation above, one standard deviation below. In this range right here, 68% of our data values are going to live every time. If we go out to two standard deviations away from the mean, above and below, then we have 95% of the data set every single time. So again, the mean is in the middle. If we go two standard deviations above, two standard deviations below, right here in this chunk is 95% of the data, which means 2.5% is going to be left on this little tip, 2.5% is going to be left on this little percent. So the majority of all data values are going to live here. And then finally, if we go out even farther, more standard deviations, if we go 3 standard deviations above the mean and 3 standard deviations below the mean, we have 99.7% of all data values. Now, for convenience sake, 99.7% is pretty close to 100%. So if we're just doing some rough estimations here, we can go ahead and say that 100% of the data is going to lie within 3 standard deviations. But in actuality, it's only 99.7%. So it just depends on how accurate you want to be. If it's just a loose sketch, then just say 3 standard deviations above and below is 100%. But remember, in reality, if you're trying to be perfect, it's 99.7%. And that's what I just said here. So when we have 3 standard deviations, we're talking about approximately 100% of the data. So that means that the max value is going to be the mean. The max value is going to be the mean plus 3 standard deviations. And then we got 2 things there. And then the minimum value is going to be the mean. The minimum value is going to be the mean minus 3 standard deviations. And that's going to give us what's called the range, which you probably have calculated the range before in earlier math classes. The range is always the highest value, subtract your smallest value. Same thing here, the max minus the min. Okay? Let's do a few examples. So, in the 2007 SAT, there was 1,494,531 scores that were approximately normally distributed. The mean score was a 515, and the standard deviation was a 114. We want to use this to describe the data set. All right, well, we just saw that 68% of all scores lie within one standard deviation. Are within 1 from the mean. So what that means mathematically is that 68% of the data is going to fall within mu plus sigma and mu minus sigma. So our upper bound and our lower bound. Let me give myself a little bit more room. So 68% of the data is going to be between mu minus 1 standard deviation, mu plus 1 standard deviation. Let's plug in what we know to get these data values. So the mean was 515, minus 1 standard deviation of 114. So my lower bound, 515 minus 114, it's a 401, or essentially a 400. So that was my lower score. My upper score is going to be 515 plus 114, which is approximately a 660 or a 659. So that means approximately 68% of all scores on this 2007 SAT were scores between a 401 and a 659. 68% of everybody who took that SAT. Okay, let's go out a little bit farther to 2 standard deviations. In other words, 95% of the data. 95% of all scores are within 2 sigma from the mean. Okay, so again, 95% means we have to go 2 sigmas above the mean and 2 sigmas below the mean. So our lower bound is going to be sigma minus 2 standard deviations. Our upper bound is going to be mu plus 2 standard deviations. Let's plug in what we know. We know the mean is 515 minus 2 times our standard deviation of 114. For our upper bound, very similar, 515 plus 2 times our standard deviation of 114. Use calculator to clean this up. So we have 515 minus 2 times 114, and that's 287. So 287 is my lower bound. My upper bound, 515 plus 2 times 114, it's 803. So that means that on the 2007 SAT, that 95% of all people who took that SAT scored between a 287 and an 803. Let's do our last one. So the last one, we're talking about 99.7% of all scores are within 3 standard deviations of the mean. Okay, so mathematically what that means is our lower bound is going to be the mean minus 3 standard deviations. Our upper bound is going to be the mean plus 3 standard deviations. Now we just need to plug in what we know. Again, the mean was 515 minus 3 times our standard deviation of 114. Our mean was 515 plus 3 times our standard deviation of 114. Now use calculator to figure out what our lower bound and what our upper bound is. So 515 minus 3 times 114. So our lower score is 173. And our upper score, 515 plus 3 times 114, is 857. So that means that 99.7% of all people who took that 2007 SAT had scores that were anywhere from a 173 to an 857. Now, it's 2015 now when we're recording this video. The SAT has changed their grading parameters a little bit. Before, the highest score was a 1600. Now, I think it goes all the way up to a 2400. I don't know. But back then, this was pretty much the normal before they changed it to the new grading scale. So almost 100% of all scores fell within this range. So if you knew this information ahead of time, you can kind of predict, all right, well, where can I rank myself in relation to everybody? Was I closer to the upper end of all scores, or was I closer to the bottom end of all scores? And that's what colleges are kind of looking at when they're ranking you, especially highly competitive colleges like Duke University, Harvard, that type of thing. When everybody is just so awesome, they're really trying to narrow it down between who is the best of the best. Who's going to be closer and closer and closer to this upper end of scores. So that's how normal distributions, just one way how normal distributions are used in the real world. Hope you enjoyed the video. Let me know if you got questions.